Okay, this is the homework help video for 3-7, the reteach of transformations of linear functions. Okay, I want to start off by going over this, and I'm putting a PDF of my copy of this reference paper right here in Google Classroom by this video. Okay, so if you lost yours, you can print this out again or just take a look at it on your phone or something. So these are all called transformations. It's when a line moves. You have an original graph, and then the new graph is like a different rendition of that. Either it moves up or down, left or right, or it rotates steeper or flatter, or it could even reflect and go a different direction altogether. Okay? So we organize this in class. This top section is about translations, and you can recognize a translation if you are adding or subtracting a number to the original function, okay? And these are the two different types. You can recognize a rotation if you are multiplying the original function by a number, and these are the different types. The different types I'm talking about are if the number's inside parentheses, it's one type. If it's outside parentheses, it's another type. Same thing here. If you're multiplying by a number inside parentheses, it's one type. Outside parentheses, another type. Again, down here, even with reflections, you have a different thing here. You're sticking a negative sign on it, but the general premise is the same. If it's inside the parentheses, it's one type of reflection. If the negative is outside the parenthesis, like this, it's a different type of reflection. Okay, so we're going to use this as we go through the homework. And I'm going to do all these four together because it's just kind of review. Okay, so number one says, identify the three types of transformations. Well, all of these are the transformations. They are translations, rotations, and reflections. So there they are. Translations, rotations, reflections. Okay, number two. Explain how a function may be reflected about the x-axis. Well, let's go to our paper. Where are reflections located? They're on the bottom. Here is the x-axis. How are they reflected about the x-axis? You put a negative sign on the outside of the function, outside the parentheses. You add a negative sign outside the function. Basically like, and I'm going to even write it like this, negative f of x, like that. That's how you do it. Explain how a function may be reflected about the y-axis. Again, reflection is this section. Y-axis, you put the negative sign inside the parenthesis with the x. So it's inside the function with the x. Add a negative sign inside the parentheses with the x. And my example would be f of negative x, like that. See the difference? This one's on the outside, this one's on the inside. Number four, what is the difference between a slope change and a translation? Well, the slope changes you see here in the middle. Slope changes are rotations. The line isn't shifting, so to speak, it's pivoting. So, slope change, the line pivots by about a certain point. Translations, the line does not pivot, the whole thing shifts up and down. That's the basic difference. So, a slope change, the line pivots about a certain point. A translation, the entire line. The entire line shifts, and that shift could be up, down, left, or right. And note, the slope does not change when you're doing this, okay? The slope stays the same, whether it's going like that or like that. Okay, so we did these all together. Now, for the rest of the paper, we're going to do the odds only, okay? So we'll do 5, 7, 9, on the back, 11, 13. Okay, we're going to do this just the same way we did in class. I'm going to zoom in so you can get a little better view here of these guys. Okay, it says for each pair of functions, describe a transformation that maps f of x to g of x. The way we taught this during the reteach was you're going from Frank's equation to George's equation, okay? So here, I'm going to put a box around Frank's equation. So number 5, Frank's equation is 5x. George's equation is the same as Frank's equation, except we're putting a negative sign inside the parentheses. Okay? So we go to our reference paper, negative sign. We're not adding or subtracting a number, we're not multiplying by a number, we are adding a negative sign. Okay? Where was it? It was inside the parentheses, right here. So here we go. Negative sign inside the parentheses, it reflects about the y-axis. That's it. That's all you have to do. You don't have to graph these. Number 7, Frank's equation is 2x. George's equation is the same thing as Frank's equation, except there is a 2 out front. Now don't get confused. This 2 is not the same as that 2. This fx right here, f of x, that is the 2x. This is another 2. We read it the same way as we did all the other ones we did in class and as we did number 5. George's equation is the same as Frank's equation, except you add a 2x. It's being multiplied outside the parentheses. So you multiply by a number outside the parentheses. You're changing the slope. It rotates about the x-intercept. Okay? So it rotates about x-intercept. But here's what I want you to add, because you already should know this. How does it change the slope? That's a number bigger than 1, so it gets steeper. Okay? The slope gets steeper. There you go. Number 9. Frank's equation is negative x minus 5. George's equation is the same thing as Frank's equation, but there's a couple of things added in. More than one thing this time. You have a negative sign on the outside of the parentheses. Okay? So what does that do? Negative sign is the bottom section. Outside of the parentheses, it reflects about the x-axis. So the first thing that happens is it reflects about x-axis. Okay, what's another thing that happens? There is a minus 3 inside the parentheses. Okay, so you're adding or subtracting a number inside parentheses. Minus 3, the graph shifts left. How many to the left? 3 to the left. That's called a translation. You can say translation or you can say shift. Those are the two things that happen. Okay, let's do the back. We are going to do number 11 and 12. 11 and 13 on the left-hand side. So, given f of x equals 2x plus 1, we're going to do this change and we're going to do this change. But what we're going to do first, we're going to graph 2x plus 1 on both of these graphs. So, My y is my f of x equals mx plus b. The b number is 1. That is my y-intercept. I go up 1 and put a point. What is my slope? It is 2. 2 over 1 to be exact. Up 2, 1 to the right. So starting at my y-intercept, up 2, 1 to the right, up 2, 1 to the right, and I can go the other way. That is Frank's equation, his line. Let's do the same thing down here. Oh, and I'm sorry. Yes, it's all based on this one, okay? All 4 of these, and we're doing 2 together. So now I'm going to graph Frank's equation again. Okay, I'm going to make the other equation in a different color. So that's Frank's equation. It says, now they're doing the transformation. Now we don't know if this is George or Henry or whoever. It doesn't say g of x or anything. It just says what it is, okay? It's the same as Frank's equation, but there's a minus 2 in parentheses. So you go to the plus minus section. It's inside parentheses. The minus makes it go to the right. So it's going to go 2 to the right. So we start at the points of Frank's equation, and each point moves 2 to the right. And there you go. That is your translation. Okay? Number 13. Number 13 is also a minus 2, but notice the difference. Here it's in the parentheses, here it's out of the parentheses. How's it going to change? Now I'm going to go ahead and jot this down. This is 2 to the right is how that translated, okay? This one, a minus 2 outside of parentheses. So we go to add or subtract a number outside parentheses, 2 down. Okay, let's do that. Here is Frank's equation. Each one goes 2 down. There you go. There's the new one. Notice, they're not the same. Sometimes they will be the same. Okay, in this case, they weren't the same. Okay, I hope this helps. You will do the rest on your own, and we'll see you in class.